In this video, we're going to look at a proof by induction question. So part I tells you to, it's actually not related to proof by induction, but it does help in a later stage of the question, which you'll find out. So u of n plus 1 or u subscript n plus 1 is what you get when you replace everything on the right hand side of the expression with n plus 1. So let's do that. In this case, it will be n plus 1 all squared and then plus 3 lots of n plus 1. Now I'm sure you guys know this if you're doing further maths, but when you square a bracket, that's the same as multiplying it by itself. So I'm just going to write this out as n plus 1 multiplied by n plus 1. And then when you expand out this other bracket is 3n and then plus 3. N times n is n squared, n times 1 is n, another 1 times n is another n, so that those add to give you 2n, and 1 times 1 is 1. You then add onto that 3n plus 3, and then you can collect like terms. So 2n plus 3n is 5n, and then 1 plus 3 is 4. If I'm going a bit fast, you can rewind, sorry about that. You then subtract from that un, which is this expression here, so n squared plus 3n, and remember to subtract everything. So n squared take away n squared cancels out, 5n take away 3n is equal to 2n, and then 4 take away, well, there's no constant here, so it's just a positive 4. And so we've proven part I. Let's now move on to part 2. I'm going to rub this out just so we have space, and I'll have to scroll down. So when you prove by induction, we first assume, we first show the initial case is true, which is where you substitute n equals 1 into the left hand side, and it should all work out. So when you do put n equals 1 into the left hand side, we get 1 all squared, or you can even write u1 equals 1 all squared plus 3n, and then that should be divisible by 2. So 1 plus 3 is equal to 4, which of course is divisible by 2. The best way to show it's divisible by 2 is to factor out 2 from the term and just leave it in that format. Now that the initial case is true, we now assume that it's also true for when n equals k. So let's write out assume for n equals k that this sequence here, instead of n, we're going to put k everywhere where n is, equals k squared plus 3k is divisible by 2. The best way to show it's divisible by 2 is by saying it's equal to 2 lots of an integer a. So let's write where a is an integer. I'm sure you guys know what integer means, but just in case, it's just a whole number, whether it's 0, negative, or positive. We now want to show that uk plus 1, k plus 1 being a subscript by the way, is also even, so is also divisible by 2. So from doing the last part of the question, actually I just write out here again, but we can replace n with k plus 1. So it becomes k plus 1 all squared plus 3 lots of k plus 1. I'm not going to bother doing this whole expansion again because I did it before, and what we did end up at was k squared minus k minus 2. Well, we ended up at n squared minus n minus 2, but here we're going to leave it in this format because n is equal to k. Moving on, how do we now interpret this inductive statement that we made? Because you always want to use the inductive statement in some format. The best way is realizing that k squared is a common term. So let's do the rest of this in a different color actually. So we can make k squared the subject of this inductive statement. In this case, it would be 2a minus 3k. Once we've done that, we can now input that as k squared into our expression of u subscript k plus 1. So it becomes 2a minus 3k, where k squared is, and then minus k minus 2. Minus 3k minus k is minus 4k, so we can write this out as 2a minus 4k minus 2. Now, how do we show that's divisible by 2? Well, the easiest way is just to factor out 2 again. And we show that inside the bracket, it becomes a minus 2k minus 1. Now, no matter what integer a is, if you subtract 2 lots of k from it, that will also be an integer. If you take away 1 from that, that will be an integer. And any integer multiplied by 2 is always divisible by 2. Then you can make a little statement and say, hence, via proof by induction, it's proven that each term of this sequence is divisible by 2. Yeah, hopefully that helped. Be sure to leave a like if the video did help and subscribe. I'd appreciate a lot. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.